Hello guys, welcome to division properties of exponents. So last Thursday you guys may have learned how to do the multiplication properties of exponents, where if we multiply numbers with terms with the same base, we can add the exponents. So here we're going to learn about division properties of exponents. So I'm going to start off on the right side. Over here I have 5 to the 7th over 5 to the 3rd. So when I have 5 to the 7th, this I can write it out as 5 times 5 times 5 times 5, 7 times. And on the bottom I have 5 to the 3rd, that's 5 times 5 times 5. So I can basically rewrite this all out so it looks like this. So with this expression, you guys know how to do what's called canceling out, when we have the same number on top, or the same term on top as we do on the bottom. So here I have this 5 can cancel out with this 5. This 5 can cancel out with this 5, and this 5 can cancel out with this 5. That means that when I simplify this and all these 5s canceled out, what is left? What is left is 5 times 5 times 5 times 5, and I can rewrite this as 5 to the 4th. So if I look at this again, how do I get 5 to the 4th? I don't want to do this every single time. It takes a lot of time. So how else can I get 4 if I have 7 and 3? Go ahead and think about it. If you guess that I could get 4 from 7 minus 3, you are correct. So when I simplify the expression, 5 to the 7th over 5 to the 3rd, this is division, so hence this is the division property. I'm going to do 7 minus 3, and that gives me 5 to the 4th. And that's what I got over here, matching terms. Alright, let's try it with the variable. Let's try it with a. Over here I have a to the 5th over a squared, and I can rewrite out a times a times a times a times a divided by the division sign using the division property, a times a. So now I can just cancel out, cancel, 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 cancel. Same thing on top, same thing on the bottom, I can cancel out. And I'm left over with a times a times a, and that is correct, a to the 3rd. And again, if I want to apply what I kind of recognize over here, over here I did 7 minus 3 and I got 4. Over here I can do 5 minus 2 and I can get 3. So right here we'll have a to the 5th over using or divided by a squared is going to be equal to a to the 5 minus 2. That's going to give me a to the 3rd. That is the same answer I got over here. So for this quotient rule, here we have a to the m over a to the n is equal to a to the m minus n. Sometimes you guys might need to use parentheses because the n might be negative. Notice how they also have the same base. This only works when they have the same base. Then you can subtract the exponents. And that's part of the facts that we're going to learn right now. So some of the facts that we're learning right now, cool fun facts about the division property, is the base, a, cannot be equal to 0. Second fact, the blank must be the same. If you were listening, I said what must be the same? That's right. The base must be the same in order to use the quotient rule. That is one of the requirements in order to use this power that we just learned. And when we do have the division rule, we are going to subtract the exponents. Very good. And m and n are integers. M and n are integers. Integers are just whole numbers. Later on, they might get a little bit fancy with fractions, but right now, they'll stay as integers. And the last line, blank, goes first when subtracting. What do you guys think this one is? Which one's going to go first when I'm subtracting? So when I'm subtracting, which one goes first? The number on top or the number on the bottom? That's correct. The number on top goes first. So notice that m is going to be the exponent on top. M goes first when subtracting.